All right, okay, everybody. It's Hugo Bowne-Anderson here. I am very excited to be joined today by Nicolay Gerold from AMP Code. Nico's just had a slight technical issue, and he'll be back in a second. But I thought to start up and say welcome to today's very special workshop on how to build a coding agent with the one, the only Nico from AMP Code, who's working on one of the most interesting and exciting coding agents and coding harnesses out there. We actually just put out a podcast yesterday, which we live streamed last week, which I'll link to in the Discord. If you are in the Discord, go to the workshop channel, introduce yourself, say what's up, and let us know who you are and where you're watching from. I'm in Sydney, Australia. Nico's actually in Munich, in Germany. So let's get everyone building agents around the world. A bit about Nico. I mentioned he is building AMP. He's a software engineer at SourceGraph. And he's the founder of IceBark as well. We teach a lot of other workshops at Vanishing Gradients, both free and paid. Check them out in the description. And if you're in the Discord, you'll hear about them as well. Hit like and subscribe, share with a friend, and check out our Substack and all of those fun things. So while we're waiting for Nico to join, I'm actually join again because he was just here. What I'm going to do is share my screen and show you what we'll be doing today. Okay, so this is the repository we've shared in Discord as well that Nico set up, how to build a coding agent. Okay, so the real idea, of course, is that an LLM will predict the next token from its training, pre-training, post-training, of course, and context. And you don't worry about the weights, right? So the entire output is a function of the input. The prompt plus every tool result the agent pulls into its window, and context engineering is deciding what goes into that window. And now, without further ado, the one, the only, Nicolay Gerold. Are you there, Nico?
Can you give me permissions again?
Yes, and so we are live, just so you know. And I've just been starting to talk through your repo. Your video is not... So you should have permissions now. So please excuse the technical errors. We can build agents. How many AI engineers does it take to figure out Zoom?
Now?
Yes. Oh,
No.
no, it
No.
says Nico has started sharing screen, but I cannot see your screen.
Really laggy. I can't hear you.
So Nico, what I suggest we do is I share my screen, and we can go through it together like that. Does that work?
Yeah. Could you see my screen? Yes, right?
I could not, no.
What? Now?
No,
Like it
no.
displays me everything. Your screen sharing and participants can now see your screen.
I sadly cannot. If people on YouTube, let me just there's a 20-second lag on YouTube, so it's actually very difficult for me to say. And we are live, so I think let's move on. And
Yeah.
what I'll do is share my screen, and it's going to be a dastardly duo of AI engineers trying to hack a Zoom to YouTube workshop. But once again, welcome everyone and welcome Nico. Nico, I was just going through the one idea, so maybe you can just talk us through a bit about context engineering, and then we can get through to the arc of where we are and where we're going.
Yeah. I think if you think about coding agents, I think by now they're all about the context. And this is something I have to remind myself constantly. All that the LLMs are basically seeing is just a blob of text, nothing else. And the entire behavior is based on that. And the all the tool calls, all the assistant and user messages is just basically semantics that we have taught the model through fine-tuning, through supervised fine-tuning or through RLHF. And through that, it learned the behavior of like just through basically a very simple method, which is basically next token prediction. And this also means like the entire behavior is determined by the input, so by the context that you have in the context window right now. And by that or through that, you basically want to have a very high quality context at all times that actually gives you the relevant input so the model can constantly make good decisions.
Absolutely. And it's weird, right? Because we do all this work for context engineering and harness engineering, which we'll get to, in order to wrangle, all these function calls and tool calls and memory, and other aspects of the context layer. But we are just putting tokens in and tokens out. Of course, then tokens out can actually call this function, and agents these days have that hooked up to tool calls that then go and execute that function for you, right? But it is still just tokens out.
Yeah. And I think like it's for one, I think like really fascinating, like how much intelligence comes from like such a simple behavior, but it also shows you like the how much the modeled architecture, like by having such a simple model architecture that can scale massive amount, like how much you can actually squeeze out of that. And the context engineering, I think like it started out very interestingly because it was really manual. So it was, I think like Dax Horthy is known as one of the people who coined the terms, and he had this elaborate process set up that he actually wrote to files constantly and pulled them in again. So it was very manual to basically reset the context window all the time and reduce the length, but also reduce the amount of noise you have built up in the context window. And and this is for me what context engineering is. It's basically deciding what goes into the context window. But I think like as opposed to like 1.5 years ago, I think like the least amount should be done by the user. I think we are now entering in a domain that the models are smart enough that they can do a lot more for us, and at the same time that there shouldn't be anything that the user can do that the human can. So basically everything that the user can do, the agent should have access to that. So basically all the different tools, all the different functionalities, he should be able to run all the dev servers, everything. So it can gather all the different information, all the context, but also get back pressure or feedback on its work.
Yeah, absolutely. And something implicit in that is, for a couple of years now, we've been hand rolling context a lot. It's been a manual task. And how do we get the machine to help build the machine? It's the outer loop of context engineering, right?
Yeah. And the for me, it's like I think today I want to talk about a little bit about the different parts or how it evolved. And I think like it's we're gonna hit like two different topics. Like for one, how to build a coding agent, and for the second, like how to do context engineering in a coding agent or with a coding agent. And I want to focus a lot on what we talked about in our podcast last week as well, is the Kirby effect that the models continue to acquire more functionality and more intelligence, which just consumes feature from the harness. And I think like context engineering shows that really the best. And it also shows you like how to actually build a coding agent because you consistently have to think about, okay, what's now possible with the new model generation that wasn't possible before, but also what of my features are irrelevant now and I can just throw them away because the model is actually capable enough to do it on its own.
Totally. So I do want to talk about the arc, but maybe quickly we can just tell people what to expect today. So we'll be going through the core loop, then go through harness engineering, and we've always almost hinted at that. Then historically, compaction, which is agents essentially compressing the history of the conversation so that it can fit it into the new context. Why it failed, turned into handoff at AMP, and then now why it's back. Then planning, thinking through handoff, RLMs. Then this is super interesting, and we're getting into Pi today, of course, and I'll actually post Armin's wonderful blog post on Pi. Pi originally had four tools: read, write, edit, bash, and celebrates the idea of writing code and extends itself with code, but then thinking through, do we actually need read, or is bash enough? And then getting into edit tools. So is there anything else you'd like to add before we kind of go through the arc of what we've seen?
No, I think that's good. I would love to share my own screen, but somehow my permissions are really borked with soon.
I can't
So
imagine how awkward it is to have, especially an Australian standing upside down in the future on the other side of the earth.
yeah, we
Um,
now have Hugo who is acting as my hands.
exactly. Well, and this, I'm the harness. You're the brain, and I'm the harness, right? And actually, let me, now I can really do this. Krang, Teenage Mutant Ninja Turtles. This is, when I tell people about harnesses, this is the image I usually, something along, well, that's not quite quite the image, but let's go. Yeah, this dude, right? He's the little brain who can't do anything. That's the LLM. And then you give it a body, and that's the agent harness with the stuff that will send emails, read databases, ping APIs, fire everyone. Once you, of course, that's the goal, right? Once you have an agent, you can fire everyone. Half joking. What people call late capitalism. But Krang. So I'm the body and hands for Nico today. So let's go, Nico.
Let's go. Yeah, if you want to go into the core loop in the docs,
Great.
you can just
Um,
look on the link. Yeah.
fantastic. And also, we should just say we're not going to execute any code today. And why is that, Nico?
Because I think like I could be executing code if it was on my machine, but or I would have, but we're gonna skip that today because I can't screen share. It's I think like everything that you have in that doc, you can one shot with an agent. So hand coding it or building it live, I think like doesn't really have any value. And a lot of the stuff is more conceptual. And I want to show like how we at AMP and how I think about like when we are building agents and how we are actually building the harness and tuning it. Because I think like this is something that's not so often talked about, and I think that's often also malpracticed. That a lot of coding agents either overdo it or underdo it, and there's like a balance you always have to make, and a willingness of like ripping out features, but also retrying stuff that just didn't work before.
Totally. And to that point, like implicit in that was you could, anyone watching, go to this repository, give it a star, fork it, clone it, and point your agent at it, and get your agent to work with you and us as well. So let's go. I
Yeah.
mean, an LLM is a loop. It's tool calls in a loop, right?
Yeah, it's an LLM, a loop, and enough tokens. I think like Thorsten put out this like now godlike article at the beginning when this whole arc started, which is like how to build an agent, like an emperor. The emperor has no clothes. That it's basically it's very simple how it works below the hood, and it's basically just a loop, an array, and tool execution, and that's it. And what you basically send to the model at every turn is like what you see in the ASCII diagram is you have a conversation array which is constantly building up with additional messages, and the messages basically have some tags in JSON which basically declare its type, so it gives it some additional semantics. And it's then just basically reformatted through something that's called a chat template that basically takes the JSON and spits out a blob of text, which then usually has a form of XML tags, which basically just tell the model, hey, this is this type of message. And based on that, it has learned through its training to pay more attention, for example, to the system prompt. And basically the conversation is resent to the LLM at every turn. And what the LLM then basically spits out is more of this XML syntax, which is converted into tool calls. And you basically see that sent from the model as a tool use. And the tool use usually has multiple things. For one, it has a type, which is the type tool use, and it always has a name for the tool it wants to call. So for a very basic agent, it's basically just something like read, a bash call, an edit file call, and it emits that. And your job basically as the harness is only to, once the tool call has been finished, you take the arguments and you just basically execute the tools. And then you might ask, like, how does the model actually know which arguments to use? And this is something called like the tool description and the tool schema, which are two things that you actually feed into whatever model you're using. And this basically is like a function. You have a doc string for the function, which is the tool description, which tells the model when and how to use it. And you have the arguments, which are basically the function arguments, which describe what each argument represents and what are valid values. So for example, for a read file call, I will tell the model to give me a path. And then the question is like, okay, do I do absolute path or do I do relative path, or doesn't it matter at all? And I will just resolve it in code in the background.
Mm,
And at the moment, most coding agents actually, for example, use an absolute path um, for reading files because it's just simpler to resolve and you have to handle less logic on the hardness side. And through that, the model basically just emits like file path, the path, for example, to user Nicolay, how to build a coding agent, blob main docs core loop.md. It emits that, and then you basically in the background take the argument, parse the JSON, and then basically execute the logic to read the file, and then feed it back into the LLM as a tool result. And the tool result is basically another special syntax, which just tells the model, hey, for this tool use, we got this back, and now continue with the loop. And we do that iteratively. So every single turn, we just feed in, we append the tool use we got, then we execute it, we append the tool result we got, we append it to the conversation array, and then we basically feed it back to the model. And through that loop, we constantly basically get further and further along the task. And the model
totally.
just starts solving it and then at one point starts editing.
I also I'll show a slightly different schematic of how a tool call works. And this is a blog post that I wrote called How to Build a General Purpose AI Agent in Python, which was inspired by Thorsten's post in Go, but via Ivan Leo's post in TypeScript, actually. And I use this, this is from the Gemini team, this image. Where is it? Yeah. So people may be familiar with this, right? Where you have the prompt go in, then the model quote unquote decides, will I complete it to give use the completion endpoint to give an answer, or will I use a tool call? And if it uses a tool call, then perhaps it will then execute that tool call and send the completion out, or it will go in a loop. And Nico, you said really nicely that descriptions can help it figure out what arguments to use and that type of stuff. And I love the example, like models are smart now. So if you have a get weather tool or function that pings a weather API and it expects latitude and longitude as arguments, but I say, what is the weather in Sydney? Models will automatically, without even telling you or worrying, like convert that into latitude and longitude to pass as arguments, right?
Yeah. And I think for one, most models are general tool callers. So they are capable of basically executing or generating the arguments for any type of tool. But at the same time, they have inherent biases because the different model providers are training so much on their own coding harness that porting from one to the other usually doesn't work. So running an
Mm,
OpenAI model on top of Claude Code, the model can call the tools, but it's very biased. So it then decides to not call certain tools. So for example, what I've seen is then when I, for example, give an OpenAI model or like an Anthropic model a shell command tool, which is basically the bash tool, but in the codex harness, it uses it way less and way less
Mm,
frequently. It decides to use sub-agents way more to actually do more of the work. And
interesting.
through that, you actually have to really tailor the harness to the specific model and see which tools are actually necessary and which tools the model also likes to call. And this is actually why a harness is still necessary, because figuring that out and what tool makes this really necessary and what are the best tools for the model and how you can actually enhance the performance is actually where a lot of like time goes into to actually figure that out. And if you quickly go into the core loop main.go file, I think like we can.
Yep, I will. And what I'll do is I'll open that in another tab. And hopefully we get to this, but a provocation there is, don't we just need one tool? Can't we do everything with the bash tool? But that's something that we'll put out there as another open loop and come back to later. So which file would you like to go to?
The main.go, yeah, the bottom one. And if you scroll down
So this is in Go,
yeah, a
but
little
we
bit
won't
more.
be using we'll be using TypeScript today as well, right?
Yeah, we will be using TypeScript mostly. This is just basically I ported it from Thorsten's blog post, which I actually in each document I basically have an explainer how everything works, and then on the bottom I have resource links to the different resources which give you more detail, and I also link to Thorsten's blog post on that. And
Okay.
this is basically how the loop works. And if you continue scrolling, I will just narrate as I go. You can see the tool definition and the agent, basically structs, which are basically like define a set of fields. So for example, an agent in our case is a client for Anthropic, is a set of tools and a get user message call. And the get user message basically only invokes in your terminal a simple logic that it is listening for text input. And this basically defines an agent. So it's very basic. And if you go to the tool definitions,
So whereabouts are they? Which lines? Oh, here we go. Nice.
the here execute tool is good.
Great.
Here you can see like we have tool def, we have found, and we have a set of tools. And in there, we basically say, hey, execute tool. We see whether the tool name that the model actually emitted is available. And if it's emitted, we basically take it and just call the function which is associated with that specific tool. And if you go to, if you scroll down a little bit more, you can see basically that we just use the Anthropic library to emit the tool results back.
Hmm.
And this is very interesting. Like you have the tool param, which is basically just three things: the name, the description, and the input schema. And that's it. So it's not really a lot of stuff which goes in there. And the different model houses have a little bit different flavors of how they define it. But it's basically the same structure every single time. You have a name, you have a description, and you have your input schema. And the
Yeah.
input schema has the arguments. And this allows you to basically figure out how, or like create a set of tools which should be very composable. And this is what makes Bash so good
Hmm.
because it's really composable and allows you to do a lot.
Absolutely.
But usually you want some additional stuff on top of that. And in the past, like when we got started, we really needed like edit file, create file, bash, read file. But now the models are so good at this loop and so good at the behavior that, for example, read file you can already throw away. You can't just give it a bash tool, and the model has been trained on so many shell sessions and so much code that it actually knows how to just read files through bash by using something like set or cat. And this also gives the model the capability to actually filter more because it can grab on top of it. So it doesn't have to read the entire file every single time, which used to be a massive issue in like the early harnesses, especially with like Sonnet 3.5, which feels like ages ago, that you ran out of context windows so fast because the model just read a really large file and we hit the context limit already. And then the people started putting basically limiters in place. So when you read a file, you added two additional arguments, which is basically a start line and an end line, and you only read between those lines. And if the model tried to read a file which is larger than a maximum number of lines, you basically fail it and tell it, hey, add these two arguments to basically restrict the number of files, which works, but at the same time, it causes a lot of bad behavior in really big files. Because if you have, for example, in in our repo, we have one which has like 5,000 lines of code, which isn't even that big. And then the model first has to figure out like what parts of the file are actually relevant and where is the relevant piece of code. And usually it really starts to run in a loop of emitting like 20, 30 tool calls and read in like 50 line increments until it actually finds it, which is very costly overall. It would be more efficient if you could just read 500 lines, but usually because then the model runs out of context windows so fast, you have another issue. And I think Bash really avoids that because it can compose it better. And it also has a little bit more tools at hand to actually figure out the right lines of code to read faster.
Totally. And I'll add a few things. I don't know Go. I can't read Go code. I don't read it. I don't even write it. What I'm seeing is that once again, we're not using even the Anthropic SDK yet. We're just using an LLM, right? And we're building, hand rolling the tool calls
Yeah.
with it.
Yeah.
Nico mentioned something important, which is all the different providers have their different APIs, which can get pretty annoying. I like using Pydantic to abstract over that when I want to switch out different models. I presume you use Pydantic or hand roll your own stuff there as well to make that less frictionful for you.
We hand roll, so we implement our own wrapper around the different providers. I
Yeah.
think if you want something in TypeScript, in the Pi package, so Pi is basically a really minimal coding agent by Mario Zeckner, and it's really great what he built. And I think like it's basically the minimal coding agent that Thorsten laid out, but really well engineered. And he has basically one library, which is called PyAI, which just gives you an abstraction on top of every provider, which makes it really easy to call all of them.
I've
And
just
in
linked to
this file,
Armin's Pi post in Discord as well. So
if you scroll to the bottom, you can
that's
see
cool.
a little bit further up. You can, for example, create new file. This is the tool logic. And if you scroll a little bit further up, a little bit further, a little bit further, here you can see the edit file input. And this is basically what I talked about before. The edit file input is the schema that you send to the model. And in here, we basically tell the model, hey, give me a path, give me an old string, and give me a new string. And edit file in Cloud Code, for example, to this state is still this. It's just a string replace. So the model is just emitting two strings, the old string and the new string, and it then replaces it. This has a bunch of failure modes that we will talk about in a later section, but I think it tells you like how simple it actually is. And I think like this simplicity was one of the breakthroughs why Cloud Code emerged. It's because it's really easy to understand and it's really easy for the model to just repeat the content it has seen in a read file call and then generate a new one. And here you can also see the basically description, the name,
Well,
and
this
the
is
input
actually, I
schema.
want to talk about this because this is important, right? But it used to be more important. So naming your tools well and writing your descriptions well used to be really important because LLMs weren't that great at choosing the right tool. Whereas now, you want to give it a good name, but you don't necessarily need to give it as good a description as you used to, right?
I I actually disagree.
Oh,
It's
well, you're the expert.
I think for if it's a really common basic tool, like
Mm,
EditFile, for example, you probably don't need a really elaborate description because
mm.
it's so trained into the Anthropic models that they will be able to handle well.
This is
But
the
you can't
curly
really
effect, though, right? This is,
yeah.
so what we were building harnesses around 6 months ago, if there was enough training data, then the RLVR, man, it sucked it up and they're good at it now. So you kind of need to strip away that part of the harness.
Yeah, but it doesn't extrapolate to other providers. So for
Hmm.
example, if I give the EditFile tool to an OpenAI model, it will probably perform way worse because OpenAI is training on a different edit tool, which is called apply patch, which
Hmm.
takes hunks instead of raw
Of course.
strings,
Yeah, yeah.
which is more token efficient. So the edit file tool, I we have actually benched it. It has the OpenAI models have performance issues with it. So you would actually need a way better tool description that tells the model what to do
Mm.
because it's more out of distribution. And this is one thing which is like one of the assumptions of mine. When you're hitting a coding task, for example, because all of the providers have their own coding agent and are training so much on coding tasks, they have an inherent bias to the tools in their own harness. Whereas when you're working in an area outside of coding, they are way more flexible to use other tools. I think they have some functional fitness once the model knows it's a coding task because they are routing to certain subnetworks, which are probably optimized or more optimized for their own tools.
Amazing. And so, look, we've been talking about OpenAI and Anthropic. It's a shame we haven't really been able to mention Gemini, but it is July in 2026, so that's going to be a tough thing to do. I also just want to say, at some point, hopefully, we're at an interesting point in history right now, Nico, in that Fable has had public release finally again. And GPT 5.6 has not had public release yet, but will in the next 24 hours. So perhaps later in this live stream, we can talk a bit about those different models and what it may mean for builders. But let's not do that
Yeah.
quite yet. Where do you want to go
Scroll
now?
down a little bit. And if you want to revisit it, I basically break down the entire core loop in this document so you can just read through it. And I think to contrast it with Pi, I think like Pi is really a production loop in comparison to what Thorsten put out. And there are a bunch of things which make it more production, which like a lot of the model providers, including us now have, which is like for one sessions. And basically every message is appended to a JSON-L file for Pi, for example, and stored locally on your disk. This means that you actually can then like close your laptop, come back
Retrieve.
to it,
Yeah.
and continue it. And also streaming. So the coding agent Thorsten build is a really basic example. It doesn't stream. So you just tell it something, and once it's finished, you see it. Usually you stream the responses. And this is surprisingly annoying because officially, like you have these server sent events, which you're usually using, or now WebSockets, which also send the events. Um, with the different providers, and every single provider has their own form of like completion endpoint, which is for OpenAI, for example, the responses endpoint or the chat completions, or the Anthropic responses one. And they also have their own streaming spec. And while streaming, you basically parse deltas so you can display something to the user so he knows what's going on. And once the streaming response is complete, only then you actually do work. So only once the tool result is completed, tool use is completed, you actually do the tool execution. And I will actually like, if you are really curious about it, I would just spend a day or two to actually read through the Pi source code because it's actually a really good example of what the different primitives are that you have to think about when you build a coding agent, which is basically the tool list, the system prompt, the the user messages which you're getting, guidance files, which are agents.md files, which are placed in the repo to tell the agent what it's supposed to do, and for example, truncation and compaction. And they have basically built everything in a very readable and only in a few files. So it's actually, you can go through the code in a few hours and really understand it.
The system
And
prompt is lovely and short as well. You don't need that much.
you don't need that much. I think you could do way more. But I think like for Pi, their focus is being really extensible and being open source so everyone can make it their own. So I think like having a short system prompt is sensible. For us, we are more like batteries included. Um, so we tune the system prompt a lot, so it's way longer. And you can squeeze a lot of performance out of the models by actually tuning the system prompt and asking more and more of the model.
Hey, I was also, you've got steering next, which is getting really nice in a bunch of, I mean, steering is lovely in your work. It's been fun in Codex, and it seems like Claude Code is like catching up with steering to a certain extent. For those who haven't steered per se, it's where you can inject a prompt or a message while it's doing work. And it used like coding agents and harnesses used to be pretty, but like it'd stop it, it'd like, and now it's like smooth. It's really smooth driving. Like it will incorporate it. And you and your team were at the forefront of doing a lot of cool steering stuff, Nico.
Yeah, so steering and follow-ups. I think like this is something that's partly misunderstood. And it's there are two different things in theory. So steering is usually, or if steering used to mean you send a new message to the agent and it interrupts what it's doing right now.
Hmm.
And now it has evolved to something you don't interrupt it right away, but you actually wait for it to complete
Mm,
what it's currently doing. So you actually don't waste the cost you already incurred and the tokens you've already spent, and then inject the user message
mm.
once it's complete.
But it's complete
And
in one step in the loop. It
yeah,
hasn't completed the entire reasoning loop.
yeah, in one step of the loop. This is basically steering now. And this is a little bit confusing in the Codex app because they actually show that the user message is sent right away. But if you actually look under the hood of what is happening, they are just basically they is doing what I just described. They're capturing the user message, they're waiting for the current inference call to complete, and then they are sending it together with the two results of the tool use the agent has just
Totally.
emitted. And the follow-up is basically the other thing you just said. It's when you usually can do something like command enter or command shift enter, and then
Mm,
it's a follow-up, and then you don't send it right away, or it's not sent after the inference completes, but only once the complete agent is finished. And this is probably good to know. There are two different types of stop reasons for the agent. One of it is tool use, where the provider basically tells you, hey, we emitted a few tool calls that you have to execute. And the other is end of turn. So basically, the end of turn means, hey, the agent has done its work, it's completed, and it's now waiting for user input again. And a follow-up basically sends the user message once the end of turn has been reached and then basically follows up with the user message so the agent can continue working.
totally. Also, dude, I love that we have hooks next. People are like, do you build sub agents and use sub a? And I'm like, dude, get with a hook and a cron job first, for real. I mean, just being able to. So, if anyone's used OpenClaw or Hermes or anything like that, when something happens, when your claw or Hermes does something and it sends you a message on Discord or Telegram, that's a hook. It's essentially a trigger, right? So being able, and this isn't just agents and that type of stuff. This goes a long time back in software. The ability to have events trigger other events are essentially the principle behind hooks, right?
Yeah. And the hooks allow you to build so much stuff. So
Mm,
hooks in combination with all the other stuff, like you can use hooks to steer. You can use hooks, like our, for example, permission system is implemented via hooks. So one example is basically the before to call. So you can actually say, hey, when the model emits an edit file call, you can show a message to the user to actually permit it or not, which I think you shouldn't do anymore. Um,
mm,
but as a few people still want to be in control. I think like permissions are now, I always run in dangerously allow all, and I just allow it to do everything. And I rarely see any misbehavior. So we haven't had any bad database deletions or anything. Um, the worst thing that probably happened to me once is that I force pushed on a branch. And I think like
I did that
and this
before
was
agents as well. So
Yeah, it's like I've done it as well. So I
Yeah.
think like this is, I think you're slowing yourself down more when you have permissions because you have to be constantly in the loop and look at it and check whether it's actually valid. And I think like most people who actually still use it are just basically hitting approve every single time
Mm.
and not really reading through the code. So I think at that point you can already say, hey, let's skip permissions and do it completely.
And check
And
out our podcast that's in the Discord for whether Nico actually reads code anymore or writes it. So, do you want to tell us about cancellation and then tell us what's not in the list?
yeah, cancellation. I think like this is something that is surprisingly annoying to build, and I know that also from us. It's like in cancellation because you have to cancel. There can be a lot of stuff going on at the same time,
Mm.
and you basically have to wire it through the entire code because it could be a tool call that's at the moment running. And when a bash tool call is running on a system and the process is running, you have to cancel that when the user cancels actually the current turn. Or the inference call which is running, you have to cancel that as well. And it gets more complicated once you get into area where you have stuff which is running async. So for example, if the model calls a sub agent and decides to basically defer it, and I think like Codex, for example, has that it just the sub agent is called and the main agent just continues and it keeps running in the background. So I think like on cancellation, then a big question is like, hey, do you actually cancel the sub agent as well, or is it just continuing? Or in bash tool calls, like often it's running tmux, for example, and you usually want to kill the entire thing.
Mm.
And this is why actually abort signal are really important to get right because there is a lot of stuff which could happen on user devices when stuff continues running in the background. Then you get into memory leaks or stuff is running and just pure confusion. And what's not in the list, I think like Pi by design is very minimal. So it doesn't have planners, it doesn't have memory systems like OpenClaw where it does this streaming cycle where after every session it basically tries to learn what it has learned. It also doesn't have a lot of safety, so which would be the permission system. And Pi basically expects it to build it yourself. And by that, it also only have the four default tools, which is read, write, edit, and bash. And I think this is also one of the limitations of Pi. I think the read, write, edit, and bash tools are very optimized for Anthropic models, but not for OpenAI models. So when you use the Pi harness with other providers and other models, I think you have to do way more lifting to actually get it to work well and get good, really good performance out of it than if you use it with Anthropic model. And but I think like we will talk about that later more in the later documents.
Yeah. And I also want to and I've read this online live a few times, but in Armin's post, there's a section called "What's Not in Pi" as well, and he mentions that MCP is there's no MCP support. And I want to quote him. He writes, "This is not a lazy omission. This is from the philosophy of how Pi works. Pi's entire idea is that if you want the agent to do something that it doesn't do yet, you don't go and download an extension or a skill or something like this. You can, of course, but you ask the agent to extend itself. It celebrates the idea of code writing and running code."
Yeah, and I think MCPs as well are the bane of my existence.
Hmm.
I implemented the MCP
Join the
wrapper,
club.
and it's surprising because the MCP it still supports a lot of old transports, so you have multiple transports for MCP, and a lot of servers aren't really up to date, but a few of them also implement really new features, and it's constantly that something is breaking or something is bork, and you have to keep it up to date, which is just pretty annoying. And I think also the how servers are implemented are is often very poor. And one example, like from last week, is the post hoc MCP has 180,000 or even 200,000 tokens in its tool schemas and descriptions,
Hmm.
which is almost the entire context window of the GPT models, which is like 255,000.
It's also the effective
So
context window of the Anthropic models, as far as I'm
yeah,
concerned. We're told it's 1 million, but far out, I can get stupid Claude after 200K or 150.
yeah. So I think like MCPs, unless you absolutely need them, I would always rip them out and just remove them.
Mm,
And when you have weird context window usage, where you see, hey, I'm paying $4 or $5 on my first request already, it's probably your MCPs which are wasting a lot of tokens.
totally.
Nice. Do you want to move on to the second part?
Yeah, and just if if you've cloned the repo, go and do the demo, and play around with it after the workshop. So yes, let's go to the second part. So just a reminder where we're at. We've just covered the core loop of an agent, going through how to build a basic agent in Go with four tool calls, and then the structure of Pi, the minimal coding agent. Now we're going to get into some harness engineering. And as we know, today I'm Nico's hands and arms. I'm his harness, and he's the LLM. So do you want me to go into this markdown, Nico?
Yeah.
My LLM brain?
And the I think harness engineering is already it's a very loaded term. And it's for me is harness engineering is basically context engineering, but for both the user and the agent. So you want to give the user and the agent the tools to actually pull in good context and avoid bad context. And that's everything. And if you look at the core loop, everything that ends up in conversations is basically one of three types of context. It's user instructions, which I include something like what the user actually wrote, the files he tagged. So basically add mentions when he actually wants to mention specific files, agents.md files, plans, or skills. And in a lot of harnesses, you can actually invoke skills and they're automatically pulled in. And these are basically your instructions that you're giving to the model, the knowledge you're imbuing. The second part is environment feedback or back pressure, which I think is the most important part if you actually want to get good results out of an agent in your code base. And the third result is the two results we already talked about. And all of that basically has to be improved in the harness. And this is basically like a lot of my work goes into how can I actually improve the three different components? How can I improve the user instructions? How can I improve the environment feedback? And how can I actually improve the two results? So I maximize signal while minimizing noise. And I will never get rid of all the noise because the model will always have to explore a code base, for example, first before it actually can identify the right files which are relevant for the task at hand. So there is always going to be some noise present, but I can basically reduce the amount of noise through doing some different things. And if you scroll down a bit, I think one clear example, yeah, into the list. One one interesting thing for the user instruction is basically the agents.md files, the guidance files. And the agents.md files, you basically put them across your repo in different directories. And the model should basically use them as instructions of how to act in a repo or in a subrepo. And the most important one, which you see in almost every single code base by now, is basically the root one, where you have in the root of the repo, you have an agents.md files, which basically tells the model how to run the different commands, like how to start the dev server, how to run the tests, how to run a linter or formatter. And OpenAI, I think, states it very well that it should give an agent a map and it shouldn't be like 1,000-page instruction manual because the tags you have on the root agents.md is very high because it's included on every single thread, every single conversation. And so it should only have the most important information and information of how it can actually gather more context and gather more information about the code base. So what you see in a lot of really good agents.md files is actually references to skills that it should load in certain scenarios,
Mm.
references to documentation it can read to get more information to different parts. And then if you actually split up the agents.md, so for example, if you have like a server, CLI, web directories in your monorepo, you can put agents.md files into every single one. And through that, you basically can reduce the amount of information you have to put in the root one. And different coding agents handle that differently. So for us, example, if you're doing reads or edits in a directory, we automatically pull in the agents.md file and send it to the model as well. So the agent doesn't actually have to do the work, because otherwise I would have to tell the agent, hey, in every single directory you are, read the agents.md file first for guidance before you actually do any edits. So I'm basically wasting 1 to 2 tool calls, because it has to actually figure out, is there an agents.md file in this subrepo, and then actually read it before it actually can do work on its own. And through
Yeah.
that, if I do it automatically, I can save all of that. And Codex, for example, doesn't do that. It only basically parses all the agents.md files, which you have in your repo, up to, I think, like 20,000 characters or something like that, and throws it behind the system prompt. And I think like this is always like an interesting behavior we are seeing, where a lot of people are telling us, hey, we're really surprised with AMP that they are having way better agents.md adherence, that we are following the guidance more. And I think like it's largely because of that, because we automatically pull it in, and the model actually doesn't have to do the tool calls, but it also doesn't forget to read them because they're automatically included.
I do wish someone told the models that we shouldn't be writing 1,000-page instruction manuals. You do really need to keep an eye on what they write as agents.md. The other thing, Claude, I mean, this is almost the standard, but you still need a Claude.md symlinked to your agents.md if you're going to go into your repo with Claude, I've found.
Or you just use an agent which isn't Claude, and then you have that as well. Because I think like
Absolutely.
every other one is not using Claude.md.
I like your style. Of course, I couldn't not play around with Fable the last week, though, to be fair.
Yeah, it's like I think like everyone has it by now. Um, I think like let's start with like the third one. The two results are very basic. It's basically the two results is the bulkiest and noisiest type. Like the bulk of the information which you have in the context window is coming from two results. And so a lot of the harness work is actually filtering and managing the two results. And
Mm.
what we have a lot is specialized sub-agents. For example, a code-based search sub-agent. So the model actually doesn't have to do like all the grabbing and reading before it actually finds the relevant files. It can just delegate that to a sub-agent with a new context window. It finds the relevant files, sends the files back, and then it can actually decide, hey, which of those files are relevant. So it saves a lot of work to actually not by delegating and then actually having still a set of tool calls to run, but which are more targeted and restricted to the files which are very likely to already be relevant. And
Mm.
through that, you can basically restrict the context window, but also keep the quality of the context window pretty high. And there are a bunch of like different, like Anthropic just pushed like the advisor pattern, which is basically the oracle we had since a year or a year and a half now, um, which is basically like an advisor where you ask a model for additional input. So for example, if you're writing a plan or doing a code review, you can ask it, hey, can you advise me on this? Is this plan valid? And it also can then basically read files, look at the code base, and return a response back. And through that, you basically just, by isolating that context window, you just save a lot of context. And the second part is the back pressure. And a lot of that, I really recommend the blog post from
It's
Geoff
too
Huntley.
old for you.
Sorry, which
uh,
blog post? Jeff Huntley. Yeah.
by Geoff Huntley on back pressure, a fellow Australian.
Yeah.
Um, which is basically you should set up a lot of things in your code base which the model can run, which is test runners, compiler errors, linters, formatters, but also logs. We, for example, have when we are running our dev server locally, the server logs are written to a file in the current workspace. So, and the agents knows about it through our guidance files that he basically, hey, when the server is running, we are writing to this file so you can check the logs should you do any experiments. And we are basically pretty aggressive for the agents to validate its work itself through actually running AMP itself in the dev version and then reading logs and actually validating whether the behavior is correct. And through that, you can create this back pressure, which basically tells the agent whether what it's done is correct or not, or allows it to actually reproduce bugs, um, which gives you a way better quality of output in the end. Because the agent, it can't really improve when it can't observe something. Um, so a lot of the harness and a lot of the setup in your code base should make the environment more observable.
Awesome. And I've linked to Jeff Huntley's teleport post in Discord. And of course, people may know Jeff Huntley from the Ralph Loop fame as well.
Yeah, which is basically loop engineering. Um,
Which, as
and
we
parity
discussed in the
principle.
podcast, is overrated. Sometimes useful, but deeply, deeply overrated.
Yeah, it's here. For example, the for me the test is always like it does in my code base. So this is something we are trying in the AMP code base at all times. Like, is there anything that we can do that the model can't? And whether that's actually inspecting cloud logs, whether that's looking at user bug reports, whether that's reading the dev server logs. Like, there shouldn't be anything that the model actually can't do. So we spend a bunch of time of actually writing scripts, writing better test wrappers, writing skills, for example, of how to use tmux to spin up AMP, so it can actually do all the work that we would be doing if we would be doing it by hand.
Mm,
Nice. If you scroll down, I think like we talked about it as well. It's like here there's basically the feedback loop of how we do it at AMP. It's basically we have a checked-in script which gets the standard out from the dev server, and the agents at .md fast tells the agent where the log lives, and we don't basically have to do all the copy and pasting into the agent. Hey, and this is part of the parity principle as well. Like, if you see any time or notice yourself constantly copying and pasting logs or anything into the agent, it's usually always worth writing something or restructuring your code base in some way that you can actually have the agent just do that automatically.
totally. I'm interested in this
Nice.
header. Harnesses are wasting assets.
Yeah. And I think like this is the Kirby part, that every component in a harness is basically it's an assumption the model can't do it on its own. And this expires over time. And the the best examples are, for example, plan mode, I think, which is now, I think in Cloud Code still has it. We had it as an experimental feature at one point, but we ripped it out almost immediately because we didn't think it was necessary. Because in the early models, were really eager to edit, but at one point they were good enough that if you tell it to not edit, it doesn't do it. So you can actually just tell it, hey, plan and not edit, and it will do it. So having a separate mode for that and having additional load on the user to actually remember, hey, I always have to go into plan mode, isn't necessary anymore because it's just one simple instruction. Um,
The other example I like
Compaction.
is,
Yeah.
remember when we used to do chain of thought prompting?
Yeah.
And, that led us to, stronger reasoning.
Yeah, to stronger reasoning. I think that compaction basically is also like we used to write to files and then took the files to continue a new thread. And a lot of the features that you actually have is will probably be relevant at some point. So you
Mm.
always have to revisit, hey, is this still relevant right now? And at the same time, when you add a new features, I always try to imagine like, am I building a feature right now that is benefiting from increases in raw intelligence of future model generations? So will it be more capable? And usually you want to build features that the model is barely able to do right now, but through the increases in intelligence will be able to do easily in the future. And these are usually the best features that you can add to any like coding agent or any agent at all. And the different plugins I added to the code base is basically in the Pi extensions and AMP plugins are a lot of that. Basically, they are tools that I give to the agent, which actually are prompts, tool descriptions, which are actually the work of harness engineering. And I think it's really a cool look to go through the history. And this is basically like the manual context pruning, the file-based compaction, the plan mode, and handoff, which was like more the 2024, 2025 era. And now we are entering like entirely new stuff.
Amazing. So that's harness engineering, people. And so we've gone
Let's go to
through, yeah, we've gone through, wonderfully gone through the core loop in two ways. In adding tools and doing the loop in a straightforward way, and then seeing how it operates in Pi, and of course all the code is in the repository, and then a whirlwind tour through all the important parts of harness engineering, in particular what Nico works on at AMP. And all the code here it's based on Pi, all the plugins are on top of Pi, so it's all in TypeScript.
It's Pi and AMP. And once we go into compaction, we'll talk about compaction a bit. We can take a look at the different compactions and look at the code and how it works.
Super cool.
So if you go in the Markdown file, so basically compaction. Why is compaction necessary? We already talked about the like conversation array just keeps growing. So naturally at some point you run out of space. Usually all the models are theoretically you can feed a lot in there. Practically, most models have a usable context window, which is lower than the advertised context window. So to how much context they actually can pay attention is lower than the absolute context window they have. Like Fable, for example, has 1 million of context window, but at some point it just starts to degrade. And I think it isn't like 200,000 anymore. I started to see it at like 400,000 tokens, where Fable starts to degrade and, for example, doesn't use tools as well anymore, but falls back to other stuff.
And
So, for
I'm
example, instead
linking
of
to Chroma's work on context rot in the Discord, so people
context rot,
can
yeah.
check it out. Yeah.
And so if you actually have, for one, restricted space, but also like you only have a limited amount of usable space, what are you doing if the conversation array keeps growing? And compaction was basically the first answer to that. Basically, when the window fills up, you just ask the model to generate a summary and you just delete whatever was before and then ask it to continue. And the if you scroll down to the relimit, and the real limit for me is the context size itself, or the window size wasn't really the issue. Like for one, the effective context, which we already talked about, is a fraction of the nominal context. At the same time, the output was capped, and with Cloud 3.5 Sonnet, the long context was way slower and more expensive than what we have now, because all of the inference was not as optimized as it is. So the tokens per second you got at longer context sizes was actually way slower. And so you actually could get way more done with constantly compacting. But the models weren't smart enough. So often they really lost a lot of the important information through the summary. So you basically build up all the information in one conversation, and then once you hit the context limit, it compacted and it lost all the information and instruction you gave it. And this was the main limitation of compaction, that basically it was useless because whatever you have built up was lost and the summary was so bad that you couldn't continue afterwards. And if you scroll down a little bit more, and the summary basically, this is actually a quote from my blog post, and I'm quoting myself now. It's what I know is it's like the summary lost a lot of my instructions. It lost which files were actually relevant. And I also had to repeat a lot of the, for example, commands which it ran in the previous conversation or in the previous conversation array to actually basically get back pressure from the agent. And when I thought at that point the summary was basically, or the failure was more structural, because you just ask the model to generate a summary of the entire thread, and there is a lot of information in there. By design, it didn't know what the next part of the conversation actually needed. And it just basically spit out a very bad summary of a lot of context. So it summarized what happened in a thread and not really what matters for the next part of the conversation.
Mm.
And can you scroll down to how compaction works?
Yeah, and that's also why, until recently, actually, like I far more actively, when using coding agents and these types of harnesses, actively manage my own context a lot more mindfully. Like I would build a plan with, a stronger reasoning model, more expensive, slower, and then I'd start a new conversation once I have the plan with a smaller model in order to execute and like restart it so that it didn't like dumb out because compaction wasn't working.
Yeah. And this, I think like this really shows you like Pi has one form of compaction, which is like a newer one. The earliest one, basically, it took the transcript, generated a summary, and then basically asked the model to continue. And that was it. I think like the newer version of compaction, which Pi, for example, has, is you take the transcript with all the different user messages, all the to calls, you generate a summary, but you still keep a tail of the conversation. So the last 20,000 tokens of user messages, tool calls, and you basically append that to the summary, and then the model can continue on its own. And the built-in compaction by Pi basically looks at the context window, like how many context tokens have already been used. And once it crosses a limit of like the context window minus some reserved tokens, it automatically triggers the compaction, generates the summary, appends the tail, and then it automatically continues. And it can continue basically sending a new inference to the model. Um, and this basically is the new compaction. And why it's back, and I think like this is mainly one thing. The model is just way better now. So they have trained it into the models to actually be really good at taking an existing conversation and then generating a summary which allows the model to continue the work it was already in progress of doing. And the second thing is actually appending the tail or appending some information of where it left off is actually really important. And can you go into the plugins? In .py, yes. In the extensions and into compaction. Yeah. And if you scroll down, this is something that Codex is doing, which is a different form of compaction than Pi. Instead of actually taking the tail, it just takes all the user messages and then generates a summary and then asks the model to continue. And
Just remind me, can you tell me how to wrap? Do you know how to wrap the?
no, I don't know.
Okay, doesn't matter then. We can see most of it.
Yeah. Yeah. So basically, the summarization prompt is asking the model to generate a summary of the current conversation. And then you take all the user messages and prepend it to the summary. And then at the end of this generated summary, you just ask the model to continue. And this is basically the summary prefix, which is giving a lot of the instructions. And I think like this is smarter than taking the tail because usually the user messages contain the most important information because it's actually the instructions for the task. And especially the most recent ones usually include the instructions of what the model is supposed to be doing right now. And through that, you now basically have all the instructions which were already sent. You ask the model to generate a summary of what happened and what remains to be done, and any critical data and examples. And these 4 lines in the summarization prompt are enough to basically guide the model to generate a really good summary so it knows what already happens and what's next to do. And this is, I think, like this shows you like it's very basic. It's not a complex prompt. So the model consumed all the complex logic we have done before with stuff like handoff or plan modes or writing stuff to a file and then continuing into a new thread in basically a single prompt.
This is so eye-opening. And what this is really, Thorsten showed us the emperor has no clothes, but this is like none of the emperors in the past or the future ever actually had clothes.
Yeah. And I think like this is also, I think like this is what makes it really fun to work in a space because you can never take anything for granted because
Mm.
it might be gone with the next model release, which is really interesting because every new model is basically like a puzzle that you have to figure out. It's like, how can I use it best? And what of my stuff that I actually build, what of my darlings do I actually have to kill because they're irrelevant now? And it's like, I think like Handoff was one of the hardest to actually kill.
So where do you want to go now?
Nice. Um, You want to move on to handoff? I think like handoff is a really let's
I
skip plan
would
mode because
I would absolutely love to go to handoff, and plan mode is dead and buried. And actually, I write plans with agents all the time, and I never liked plan mode. It wasn't only because of the plan mode, it was the way the user experience was, particularly in Claude Code. Like it really, when it was like select, you go from a conversation to having like select things in the terminal, and I was like, can you stop this, please?
yeah, it's for me plan mode is what I'm always wondering. The models once you mention a plan, they like to generate a lot of tokens, so they write really big files. So I usually never ended up reading them. So I think that the the benefit of a plan isn't really there. And at the same time, because they generated such big plans, it would already be easier to just see it in code and have the model write the code or implement a feature, look at it, decide what I actually want to build or how to improve it, and then give feedback or just restore it, start fresh, and write better task instructions myself.
Mm.
And I think like plan mode is dead now. I think like the models, it has been trained in that the models are doing a lot of planning themselves. And I think it started with 5.3 codecs, which actually was annoying to a lot of users, which came from Cloud Code, because it just for like half an hour, it just read files, explored their code base. And for if you look at a lot of the thinking summaries that the model sent you, what it did internally is actually build an implementation plan. By looking at a lot of code and the entire code base, it basically explored it and built a mental model of like how everything works right now and how to implement the feature in this code base and in this context. And I think like this really made it better than a lot of the Anthropic models at the time.
Yeah, and look, Siddhartha
So
has actually reminded me one of the things I hated most about plan mode. And he said the problem for him is that to actually write the plan into a file, which you want to do, you have to go into build mode as well. Claude, at least when I use plan mode, would develop an internal plan that it wouldn't even expose to me in a markdown.
yeah. And so if you go into the Markdown document
For plan
for
mode.
the handoff,
Oh, phew.
for
Okay.
handoff,
I'm glad we're not going. Can I just say before we do that though, you talked about how many tokens this stuff generates, and one, I don't want to get too tinfoil hatty or conspiracy theory. It's not a theory; it's just a conspiracy, they say. But there is an incentive for Frontier Labs to build agent harnesses that make us consume more tokens as well, right? That's one of the reasons I'm a like philosophically or socially a fan of AMP and Pi and harnesses, which don't necessarily have that incentive. But there is this weird thing that they want you to use as many tokens as possible, right?
I think it depends on what you're how you're consuming it. I think like for regular users, in the incentive for them is to use as little tokens as possible because they have a fixed subscription plan, so they want to consume as little resources as possible for the money the user is paying.
Mm.
So I think like there the incentive is kind of perverse because in a lot of cases it's just more tokens is usually more performance. When it comes to a lot of the enterprise contracts you have right now, I think like it's exactly what you said, because usually it's now usage based. So the incentive is for them to actually consume way more, um, assuming they have a margin on the usage, which they have. Um, the I think like Fable is a good example. I think like the 1 million context length is a really bad thing to set. And it is set in a lot of places. And I think like if you use Pi with Fable, it's also set to 1 million, um, which runs up the cost massively if you're doing usage-based pricing. Because once you hit a certain threshold, you're paying the basically cash token cost at every single time. And for Fable, I think this is like I'm not sure, $5 per million tokens, but this is per request. And because you're sending so many requests in a single turn of the loop, um, this accumulates really quickly. And once you cross like a certain thresholds of token, like 250, 300, even 500,000 tokens, each request gets really expensive. So the accumulative token usage is so high because getting from 250 to 750,000 tokens is probably 200 requests. So the amount of tokens that you're actually spending is nuts. So for us, I restricted the amount of the maximum context window to something way lower for Fable to actually save on the cost. So we are just compacting way earlier, so it actually stays at a lower amount of tokens.
I've also found that if you tell Fable to use its own judgment to really route things to dumber, less resource intensive models, it can do that really quite cleverly.
Yeah, it got really good at delegation,
Yep.
and I don't think we have time to go into that today with like RLMs. And I think like RLMs, the main goal was to basically improve models at delegating, but I'm not sure whether you need it anymore. I think like this is what, again, Kirby, the model is actually consuming it, so you actually don't need so much logic. But Handoff. Um, Handoff was a brain fart, and it basically came out of my frustration with Compaction. And with Compaction, I caught myself constantly when I saw, hey, I'm close to running into the context window. I I stopped, asked the model to write the current progress to a file, and told it to basically include my instructions, include the files that are really relevant for what I want to do next. And I basically wrote, hey, I want to do X next, or I want to continue what we have been doing. Write the current progress and the relevant files to a file, and include everything from my instructions as well and the important trade-offs you have discovered. And I caught doing that constantly. Basically, like every time I was close to the context window, write it to a file, open up a new one, tag the file, and just tell it to continue. So handoff was basically just a way to automate that. And handoff basically asked the user to basically write out its next instruction, so the user goal, and then it ran something which I think like especially you, like all of us which are coming more from a data science or AI space
Mm.
uh, can really appreciate. It ran a structured extraction. So it isn't just a model call where it just is writing raw text out, but it's a force to call where the model only has one tool to call, which is this one, and it basically writes the relevant files and the relevant information. And then the new thread input is basically the file mentions, which are automatically passed, the extracted information, and the user goal. And the user goal was such a funny thing I've added, because what we noticed with the first version of Handoff, the users wrote really shitty goals. So basically, what task do I want to continue on? And this caused the model to perform actually very poorly, because it didn't know what to focus on in the context window. So I started to just append the user goal to the new message we are sending in the new context window. And through that, the user actually learned, hey, I'm writing better instructions because it's going to be appended, and it's basically the instruction which is sent to the model next. So they actually spent more effort writing actually good goals. And this made the output of handoff really good because the model knew what to focus on, what files to extract, and what relevant information to pull over. And I think like this is really often like the context engineering when it's targeted at the user and the model. It's like you also have to find a way for the user to actually really give good inputs so the model can do its best work. And I think like in Handoff, this was really cool to see with just like this little tweak, you can actually get way higher performance by just forcing the user with a little nudge to write better goals and better instructions.
Awesome. So we've
Yeah.
gone through,
And
yeah.
we gone through this, and I think like I basically told the whole story in a blog post. And the compaction we want, I think like the contrast is like compaction we want just ask, it was just going after length. So it just ask what can we throw away to then continue. And it didn't focus on quality a lot.
Mm.
File-based compaction basically moved everything to the user because it was relevant, really explicit. You had to repeat the instructions every single time. And then handoff basically kept the user in the loop, but automated everything else. And this beat every compaction implementation we benchmarked it against at the time. Um, but now it's irrelevant again. And it's actually like one of the complaints we get the most is still to this day, like I want handoff to come back because it was a really cool way to control the context window a lot and do a lot of stuff manually. But I don't think it's just not necessary anymore because the models are so good at compaction that it's usually just best to just continue in the same thread and let the model handle it. And you worry more about, hey, write really good task instructions where you tell the model what it is supposed to be doing instead of worrying about something like, hey, I have to actively manage my context.
Super interesting. And I am interested. You mentioned benchmarks, and I do want to know when new models come out, or you iterate on your harness, or you rip it out and rebuild it and throw things out and put things in. How important are benchmarks versus getting it in front of users?
It's it's a real mix. I think like for new features we are building, I would always just give it to users
Shit.
and get feedback really early
Mm.
to see whether they actually like it and whether it improves how they're working with agents. And usually that gives me more as creating a benchmarks because creating benchmarks is really labor intensive.
Yeah.
So I'm kneecapping my own feedback loop of actually improving the product because I'm creating a benchmark first.
And to be clear, when we're talking about benchmarks here, we're not talking about like model benchmarks. We're talking about like AMP evals on gold data sets, right?
Yeah. So basically, what shout out to the eval courses, like the goated ones by Hamel.
Yeah.
Um, I think basically what he's preaching, where you basically have um, a an input and a gold output, which is usually like human written. So by me, for example, take a thread and I write a really good summary, and this would be one example, and I basically create an eval set for that. But because that takes a long time to actually build up, um, it kneecaps your own development because in the beginning I'm not sure whether the feature would actually help the user and make the performance way better. So I don't have to squeeze like every single ounce of performance out of it. I can just give it in the hand of a few beta users and a bunch of them, collect feedback, improve the feature first. And once I know the feature is actually really relevant, it's valuable to users, then I can start actually creating an eval set and actually refine the prompts and the logic behind it to get better and better and better. And I think like this was the first version of Handoff I just threw out there and gave it to users. And then the first thing I know, okay, performance is bad because the goal is actually isn't as good. They basically added this, hey, append the goal to the new user message. And then next, I built an eval set. And I just started basically hill climbing on the eval set until I had a really good prompt for handoff. And then basically I just improved it iteratively over time. And this is usually like mostly how I do it now is, hey, first put the feature out, get it in the hands of users as early as possible. And then once I know and once it's validated that it actually is already valuable at a degraded state, then spend the time of actually putting the effort in and creating evals so I can hill climb on that. And I think for that, the evals shouldn't be compared to benchmarks because benchmarks should usually tell you, hey, how good is a model at a certain behavior? Whereas for the evals I'm building, I usually want to be like, what's the current state and where can I improve the system prompt, the tools, and the model to actually get a higher score? So it's like, it's basically training on the eval set.
Mm.
But because that's the goal of getting way better for that specific use case, I don't mind it as
Yeah.
long as my eval set is broad enough to cover the different user code bases and scenarios it throws at it.
Thank you for that detour, and I think it's really important for people to recognize how the relationship between benchmarks, evals, and getting user feedback. Um, you said maybe we skip RLMs, but I maybe we can just do a brief tour of recursive language models. In pure selfishness, I want to learn a bit more about them from you today as well. So
Hey, Hugo, you are the hands. You can't just force me into it.
I can force myself though. Great. Let's do it. So, just sorry to recap, not kneecap, core loop of an agent. We've done harness engineering, compaction V1, file-based compaction. Talked a bit about plan mode, then deep dive into handoff. Now, what is a recursive language model, Nicolay?
It's recursive language model. I think it sounds so fancy, but it's way simpler. You basically give it code execution capabilities. You give it a REPL. So for our Python users, you give it a really nice
Oh
Jupyter
yeah.
notebook and allow it to execute code in it. And basically all the tools the model had, which is like read file, edit file, bash, becomes a function. And this doesn't sound like a huge innovation, but it actually allows the model to control the context window similar to as in Bash. Because its code is very composable, so it basically can assign the output of a to result to a variable and then run code against it to only extract relevant sections, which it actually wants to read and print out, and then only see these parts of the context. Or it can decide to not read entire things. Um, and through that, it's basically supposed to be a lot more context efficient, but also a lot more composable than regular tool calling.
Mm,
And you basically have one root LLM, and then you have a REPL, and in there it can write any code. And whether that's Python, I think like you see two main things. You either see Python REPLs or you see TypeScript or JavaScript REPLs. And through that, it can basically do a lot of interesting stuff. And in most implementations right now, I would say it isn't a true REPL because you don't, it is really expensive to run something like a Jupyter notebook at all times, which stores all the already executed state and allows you to refer back to a variable which was defined at the top at the bottom. So usually most RLM implementations right now are some container, some sandbox where you can execute code, and the model have one additional function, which is called store usually, which it can call with a variable name, and then it's basically stored in memory or in some form of SQLite database. And then at later points in the context window, it can refer back to it and read it out.
mm,
So it's like a REPL, but a little bit reduced in its functionality. And only when it calls something like print, it actually can look at the data within these different things. And I think it's a really cool concept, which came, I think, out of Stanford, but I'm
mm,
not entirely certain. Um, it's really cool. What we have noticed is like we didn't get a lot of context improvements. Um, so with it saves, for example, on the function calling theoretically, because you don't have to include all the different tool descriptions, but you still have to tell it about the tools which are available. So usually it just moves the burden. So it has a file with all the tool definitions or function definitions now, and it reads them in at the start of a thread. So it doesn't really save that much context in that domain. At the same time, it prints a lot because it actually wants to get the information. And I think like this is still, it's part of the bias that the current LLMs have because they actually want to read and see the tool results. It's so trained in that they still bias to it way more. And I think this will be improved over time. But at the moment, I don't see the context improvements by RLMs that I would have expected. But on the plus side, it gets way better delegation.
Yeah.
So for example, a lot of different harnesses have a lot of sub-agents. And to get a model to actually use it, you have to nudge it a lot to actually use sub-agents in the right scenarios. And with wrappers or with code, it actually just does it a way more in this way better orchestration because it's an easier orchestration primitive when you just have code as opposed when you have sequential tool calls.
Super cool. And for people who want to play around with this, in the repo, you can literally jump in with a Pi extension that's ported from Rollworks and see what's up there. As Nico has suggested, point out something ridiculous like a 500,000 token log file, and you'll just see, windows all the way down.
Yeah. And this is, but at the same time, I think this is something that Bash already gives you to a large degree.
Well,
Because of the,
we're about to get there, aren't we?
yeah, because of the whole Unix philosophy, everything which is running in a shell is already very composable. And by now you have so many different CLI tools which do a lot of different stuff and basically can do anything that what I can do in code and especially what I can do in the current implementations of REPLs because they try to secure it and not install a lot of packages. I can usually do way more in Bash because I have way more primitives installed on developer machines. Because usually they have everything they need to rip grab, or it's built in already. So I have a lot more functionality. And that's like part for me why I'm not seeing RLMs yet. And I think like this will change in the future because the different providers are already starting to train on it. But at the moment, I don't see what it has promised to set out to do. I think
Right.
this already leads us to Bash beautifully.
Well, this is so exciting. And I did link earlier in the Discord to your team's wonderful post, "The Coding Agent is Dead," which maybe I'll just find one of my favorite sentences with the new, and this is bloody hell, this is from February, right? So the current generation of coding agents is dead. The heart is still beating, yes, but the bullet has already left the chamber. This generation isn't the future. With the newest models, the agent, the prompts and tools you wrap around a model is no longer the limiting factor. These models can be powerful with nearly any tool you throw at them. A simple tool called Bash is often enough, which brings us to read tool versus Bash. So should we jump into this markdown, or do you want to create more
Let's jump in.
suspense? Let's do it. So, as we said earlier, Pi originally had 4 tools: read, write, edit, bash. Seems wonderfully simple, but do we need read?
No. We have it for, I think, one more mode, which is using Haiku. And we only have it because the model isn't smart enough to actually use Bash to the same degree. Or I don't trust the model enough that it doesn't use Bash in ways that would edit anything. So I actually didn't want to give it Bash. And I think all the other frontier models, GPT-5, 4, 5.5, all the Opus models, Fable, GLM 5.2, they don't need read tools anymore. And I think this is why read existed, or why did we want it? And we touched on it a little at the beginning that read got a lot more extensive. At the beginning, it was just a path, and at one point, we basically added limits. So the model doesn't have or the read tool doesn't have such a big blast radius when it reads a false file that it reads in 2,400 lines, or 5,000 lines, or 10,000 lines. And with read, you could control it way more. But this isn't the case anymore because the model is capable enough that it can actually use cat or set with it reducing the amount of lines it wants to read, and it's trained into the model already, that you usually don't have as big as a blast radius, or the model doesn't read files willy-nilly, that it just decides, hey, I'm going to read a 50,000 line file of code. And Bash at the same time gives you way more primitives because you can't really pipe one tool into another tool. Like take grep and take the output of grep and pipe it into read. But you can do it in Bash. So I, for example, could use grep on top of a set call. So sed is basically a way to read files with line numbers. And it can call set and then basically pipe it into a grep tool and basically reduce the amount of tokens by a lot. And this helps the model. And at the same time, it is also parallelizable. So when it knows it has to read 5 files, instead of actually generating 5 tool calls, which just add latency, it can just generate a single set call on 5 different files, which saves you a lot of tokens at the same time, but also a lot of tokens it actually has to generate.
Yeah. And
Um,
also, there's a little birdie on my left shoulder, right shoulder, whichever one, saying, "Oh, what if you want to search?" And Nico on my other shoulder says, "You have curl, so it's all good in the hood. Bash gets you
yeah,
everything."
I think like web search is at the moment, it's a little bit of an exemption, I would say, because it's
Well,
a lot of
let's be clear.
websites.
Technically,
Yeah,
you're right. And but if you have something like Pi, Pi can then extend itself using use curl to look up something online and then use what it finds. And of
yeah,
course, the models are so smart; they know how to extend themselves with a harness like Pi in order to build its own search tool, essentially.
yeah. And I think like this, the only downside at the moment is, for example, the structured results.
Mm,
And so basically, if you have something like images, PDFs, or something like that, you could build in more logic in a read tool that when it, for example, reads an image, just include the image. Or when it reads a PDF, extract the text, summarize it with an LLM, and then pipe it into the tool result. This
exactly.
is something you can't really do with Bash anymore. So if it calls read on a PDF, it doesn't help much. But at the same time, you either can uh, add another tool for viewing binary files, or you can just trust the model that it actually is smart enough to use certain CLI tools that actually can handle images and PDFs.
So, do you want to say much about? I mean, we've talked around why you removed it and why is it necessary. Do you want to say anything more about this?
Yeah, I think like the cap problem, I think like the pagination loops we talked about it. The what we have seen with read file, because usually you capped it, so it was only allowed to read a certain limit of files. So it ran into loops where it basically couldn't find the right information in a file, and it tried to solve it by reading more. So it just iteratively read more and more of the files and like 50 line increments and used like 52 calls instead of actually doing something smarter, like using grep first, finding the right line numbers, and then reading it, because it just basically started reading and then thought, hey, maybe it's in the next 50 lines, maybe it's in the next 50 lines, and just continued doing that. And this is just really wasteful. And in the CLI, it just instantly started with that behavior that it actually is smart enough. Hey, use grep first, or when I don't find it in set, fall back to grep and then set again. That it actually does that way more natively. Composition is another one. I think like Armin had a really good blog post. Like what you can do with composition is really in Bash is really nasty. It's like it's another programming language, and this is also like where I think like Bash tools have even an edge over RLM. It's so compositional, it's crazy. And it's also once it has written a bash tool or installs something on your device, it can use it forever. Whereas usually like in RLMs, most of the replica code is thrown away. And at the same time, I always love if you can just throw away stuff because you need it, don't need it anymore. So one less tool is just beautiful.
Fantastic. Um, one less tool, but we don't want one less than one less because we need one, don't we?
Yeah.
Do you want to tell us a bit about what we lose?
What we lose, I think, like what I already said, like non-text binary files, the policy enforcement. So, for example, if you, it's not completely gone, but it's harder. So, if you, for example, want to restrict the model from reading dot files, like dot end files, so you don't send the API keys to the model provider. It was easy with a read file because you could just take the file path, look at it, and when it's a dot file, basically tell the model, hey, you aren't allowed to read that. With set calls, which are composable, you would have to parse the entire bash call, which is a little bit more challenging. Um, but you can also do stuff like, for example, if for us, all the tool results go through a secret redaction. So we just redact everything when we see certain patterns in the tool result which resemble an API key. So we don't send it. So you can actually get around it with other logic. And line numbers for free. So the read file does line numbers, which is something the model sometimes forgets. So instead you have a header, which is .n, I think, which basically allows the model to include the line numbers in the file it reads, and sometimes it doesn't do it. So then usually the edits can fail, but this also is gone in the new models because it rarely does it, because it's all trained in now that it's actually smart enough, like, hey, read the line numbers with it and then actually use that information.
Super cool, man. So, how do you feel about moving on to edit tools versus,
Edits versus apply patch. I want
yeah,
to, I'm not sure I'm not gonna get heat from Mario or Armin on that.
I hope, I hope, I hope the heat is brought. So, look, as we've said, Pi, four tools, read, write, edit, bash. Now, tell us a bit about edit and what happens with context engineering and what your take is.
Yeah, so edit versus apply patch. I think like this is a really it's it's the same trade-off, I would say, as bash versus read. Apply patch is just much more parallel, which makes it much more powerful and interesting. But it's also a more complex tool to wield. Like the tool can do way more, so the model actually has to be trained on it more to actually use it properly. And this is why, like Cloud Code, for example, and also when we use Anthropic models, we still use the edit file tool and not apply patch because the Anthropic models aren't good at using apply patch. Um, and edit file basically is only string replacement. And our edit file tool basically takes an old string, a new string, and a path for which file you want to edit, and a replace all as an option. So basically, when you have an old string and a new string, the old string which you want to replace could match at multiple locations. So when it sets replace all, everything is replaced. But when it doesn't set it, you can't really do the replacement because you aren't sure which of those you actually want to edit. So we fail in this case. And this is how we do it. And I think like the edit file tool is a little bit more limited than apply patch in that case. Apply patch generates hunks, and hunks are basically diffs, which are then parsed and then basically taken and applied. So basically, you do something similar. Either you extract the old string and the new string, or you apply it directly, and you make edits. And because a hunk, which is basically just a name for a small diff, has a file name associated with it, in a single tool call, it can generate multiple hunks, which makes edits across files or multiple edits in the same file. And it also has something other beautiful, which is context lines, which make it very easy for the model to actually give like one or two additional lines of context before the actual edit, which basically just anchor it to tell us where the edit is supposed to be made, if duplicates, for example, are present. So if you have like the same line twice, but there are different lines over it, the model would just basically take the two lines above it, then the diff, and then this would basically already tell us, hey, this is the place to apply it, and it's not the other duplicate, which we have
Mm.
further down. And a little bit against Pi, I think like if you scroll down, I talk a bit about the edit file cool, like this is batch. And here can you see basically the patch of what it's supposed to do. And it's basically update file, and then the add in this is basically the context line. So it
Yep.
basically tells the model, hey, there's a context line, you don't have to do anything with it, and the minus and plus is basically the diff you have. And in there, you basically already see, hey, I have the file name, I have the context lines, and I have the plus and minus. So basically, I'm collapsing the tool into a single thing. It's only one argument which the model still has for that tool, and this is the patch, and nothing else. Whereas EditFile has the old string, the new string, replace all, and the path. And if you want to edit multiple files, you need to emit multiple edit file calls. And I think like this is a really beautiful solution, which I think the Codex team is the first one which put that out. Um,
That's super
and
cool.
it also replaces multiple tools at the same time. Like the Anthropic models, for example, have a create file and an edit file, whereas in a hunk you actually can say update or create or delete, and then you already have like multiple tools at the same time in a single one. So it's restricting it, but doing way more. And the interface is becoming simpler. But it's also like the model has to know more about how to actually use it. Nice. Um, Pi. Now I want to talk about why the Pi built-in underperforms. Um, the the I talked already about the edit file tool is close to what Anthropic has put out. It's basically an old string and a new string. Um, but they have implemented in a way that it's much stricter than the other edit file tools, and it's also an off distribution schema. So to make it more parallel, they basically allow the model to do a tool call, which is a list of arrays of old text and new text. So basically, it's a list of edits, which makes the tool schema much more complex. And at the same time, it diverges from the tool schemas enough, which the model was trained on, that it seems to be the same, but isn't. So the model often fails of generating the tool call correctly. And I think like this is again something, this is the function of fixedness I talked about in the beginning. The model are trained to use certain tools. And if if the tool looks similar enough, the model wants to use it in the same way. And the further down the context window you get, the worse it actually becomes usually at calling the tool in the right way. And the more it falls back to its trained in behavior. And I think like this is the main reason why the EditFile call in Pi is a little bit worse than a lot of our other harnesses, because it makes it more complex and it looks like it's the same, but it diverges enough that it makes it way harder for the model.
Super interesting. And if people want to play around with this, once again, go to the repo and check out the Pi extension apply patch, which who who ported it to Pi from Codex? Did you do that or?
Yeah, I did. I wrote all the extensions. I pointed it at the Codex repo. So it's like a
Yeah.
lot of the extensions I built, it's very easy nowadays. You can just, for example, point it at the open source Codex repo and tell it, hey, port apply patch, and it's done in one shot. Um,
How much do you need? How well versed in TypeScript do you need to be to
I don't
that
think a
to?
lot.
Yeah.
Just,
Okay.
I think you can also tell the model, hey, translate this to Python for me. The thing is, nearly every coding agent, but the Codex one is implemented in TypeScript. So all the plugins or extensions you're building are also in TypeScript to keep it in the same language. So there's little in Python, I would say. And TypeScript for agents is just the language of choice.
Yeah. Um. So there are a couple of questions I have for you, but you've just taken us on a wonderful tour through all like a lot of the main moving parts in building a coding agent, from the core loop to harness engineering, compaction, plan mode handoff, RLMs, read versus bash, edit versus apply patch. Um, is there anything else you'd like to add before I ask a few final questions?
Yeah, I think like harness engineering, it's fundamentally about tinkering and trying a lot of stuff and not getting in the way of the models, but also being really open of what you can actually do. And I think like this makes it really fun. And with when you're using coding agents to build your coding agent as well, which is where I think like Pi is the best at, because the entire code is open. It's the extensions API is really well built by Mario, that you can actually really use the coding agent to build the coding agent and create like a self-reinforcing loop of making it better and better. I think like this really is like the way I expect more and more software to be built, especially in dev tools, that you actually use the dev tool to make the dev tool itself better. And I think like this is really beautiful that you actually can tinker a lot. And actually the writing code part, it's like, yeah, we are losing it more and more because actually the agents are way faster and more efficient at writing code. But at the same time, you can let your ideas run way more rampant because you can try way more stuff. Like the amount of codes you can produce is immense. And I think like this invites a lot of slop that you just put everything into the code or as a feature into the code base because you can. But I think like you should actually use it to one, strive for way more quality, polish it way more. Like the code we should be putting in the output in the code base should be so much better because we can actually just do like 20 iterations on it or like implement it in three different ways in like an hour, which just wasn't possible before. And at the same time, it allows us to experiment way more, like try really wild ideas, which would be way too costly to implement otherwise.
Mm.
And I think like this is really like a beautiful thing to do. And I think it's really fun to build software that way, even though we are losing more of the like, hey, crafty part where I'm really writing software by hand.
Yeah, and opens up whole new worlds. And I don't want to get too cynical again, but we were talking about incentives and business models before, and what a world in which, I pay OpenAI to generate a whole bunch of slop, and then I pay OpenAI again to try to make it less slop, and then maybe a third or a fourth time to remove slop. I mean, you pay the providers to create the problems and then to help you solve them as well.
Yeah.
Um, One other thing I just want to make clear about building harnesses, because when I advise people and consult and teach, I get these questions a lot. People are a bit, I think schizophrenic around like how much do I need to think about context engineering and all of these things. And for coding agents, clearly this is incredibly important. For most harnesses, agent harnesses you'll build, especially consumer ones, you don't need to think about this at all. Think about customer service agents, right? Those you want to resolve the ticket in 1 to 5 turns maximum, right? So really thinking about context engineering isn't so important when it's such a small turn conversation. So there's almost like a bimodal distribution of kind of what you need to think about with respect to harness
Yeah.
engineering for chat applications, for some deep research ones, and for coding. Like harness engineering is a huge sprawling task, whereas for a lot of consumer-facing agents, harness engineering, you've got a handful of tools and short conversations, and it's not what you're seeing happen on Twitter all the time, right?
Yeah. It's like, and I agree, and it's like I think like if you're doing live voice, yes, you have to be wicked fast. If you're doing something where I think I would happily trade off higher quality for less speed in a lot of cases when I'm
Mm,
seeing the customer success or support agents, because in a lot of cases, it's like they're just making blatant mistake. And if I would give the agent more time or let him think more and do more tool calls, I would probably get a way better result and not require me to send 5 messages instead of a single one where it then churns a little bit longer. I think like this is always a trade-off to consider. Like, is it worth it for what you're getting out of it? And for me, at the same time, I think like this is more philosophical now. It's like don't lose the human touch. Like we at AMP, like we don't really have a support team, so we are doing our own customer support. So we engage with a lot of the users and fix all the bugs we get in the different channels and engage on X, Discord, and via email. And I think like we take away a lot from that. And I think like customer support and success is like one of the areas where actually a human touch will still matters a lot, because what the agent can actually handle and what a human can handle, which has seen a lot already, is like vastly different. And at the same time, having empathy um, with the guy who is sitting across from you, even if he's really frustrated because there's a bug in the product, I think still matters a lot as well.
absolutely. And something I promised earlier that we'd talk about. Fable got its, eventual general release a week ago or whatever it was. GPT 5.6 comes out tomorrow. On the podcast that we've linked to, you and I talked about how Fable is a step up in taste and judgment for coding. So people should check that out. I am wondering if you can tell us a bit about what you needed to do with your harness and re-engineering your harness for something like Fable.
So re-engineering the harness for Fable, I think like one thing is like I'm just asking way more of the model. So in the system prompt, I have way more expectations of what really good engineering is and what I expect it to do. And I think like this is also like I can push the taste the model already has like way further by giving it some guidelines to follow. And I think like there's a lot of stuff. Which I think is obvious for the most case, which is like, for example, deep interfaces with a lot of what a lot of people are talking about, where you really want like a narrow interface with a really deep implementation where a lot of stuff is abstracted. I think this is something that's a really good general guide which you can give to the model. Also, like the GPT 5.5, for example, it has certain patterns it always falls into. And it theoretically should follow the style, the format, the naming structures of the code base. This is something Fable is already really good at, but I can push it even harder in that direction that it actually does it. And I think with each model, like this is another thing, like you have to think about like what more can I ask of it that it's now possible? How
Mm.
further can I push it? And another thing with Fable, it's way better and it likes to delegate way more. So I actually can give it a bunch of sub agents which are specialized and do certain subtasks. And it writes really good instructions. And at the same time, it is really smart of actually not just accepting what the sub agents do, but actually thinking on it and actually giving feedback or adjusting on it and pushing back when it's not happy with the result. That with sub agents, you can also squeeze way more out of it. So for us, it's also like what models are the best sub agents to give Fable access to, which makes sense in terms of performance cost in tandem with Fable.
Awesome. And just let me ask, do you get early access to models so that you're able to build what you need to?
Ye Depends on the provider, but generally speaking, yeah.
So have you been working with 5.6 yet?
Yeah.
Are you able to tell us what without, I'm sure you've signed NDAs and that type of stuff, but can you tell us anything that you had to do with 5.6?
I don't think I'm allowed to.
I understand. Yeah,
It's
I was pushing the friendship there. I just got a message from OpenAI's legal team. Okay. I've been banned from all. Oh, my social profiles are down now. No, I'm kidding.
is I think
Um,
like most coding agents, or I think like most of the bigger users of the different providers. I think like also the really big enterprises, which are just massive consumers,
yeah.
get something like early access that they can iterate on it because it's in their incentive as well to get people to the models as fast as possible so they
Mhm.
can deprecate the old ones.
Yep.
And the
Let's
I think
let's
every
not talk about deprecation today. I mean, we've been here for 2 hours. If you get me started on deprecating models, um, but Nico, one thing you mentioned which I really like, you encourage people to like spend half a day or a day checking out the Pi source code. And I'd very much encourage everyone to do that. But if people are, I suppose, interested in just learning more about this and building more, what would you encourage people to do?
It's, I think, like, first of all, use coding agents, and whether that's an expensive or a cheap model, it really doesn't matter. I think often I can learn more from using cheap models and making actually the harness better than from moving using expensive models.
Mm,
And you also learn a lot because usually, like, when a model does really stupid stuff, often it's in your instructions because you phrase it poorly or leave just a lot of unknowns to the model or known unknowns for you. which it has to figure out, and in some cases can't figure out because it's in your head or from the domain, which isn't documented in the code base. So I think like just using coding agents a lot, whether it's expensive or cheap models, and actually trying to think about how can I squeeze more performance out of it will help you a lot because it's fundamentally about communication. And then just using it and trying to improve it for yourself and actually seeing whether you can squeeze way more performance out of it. I think it's just a fun habit to go into, even if you end up not using it at the end. And I think like we saw a lot of enterprises which put out like their own harnesses, own automations. From what I've heard of them, a lot of them are like half a year, they're barely used anymore because it's just a lot of work to keep them up to date. So this is something you have to like expect as well. But I think like you gain more of an appreciation of like what the harness actually do, and you gain a better understanding of what I can actually expect from the model and how to work with it properly if you actually try to build your own harness and improve it over time.
So good. So everyone, you heard it. You heard it from the source. Keep building. Build your own harness. Play around with it. Use less intelligent with faster and less expensive models as well, in order to push yourself, in order to keep thinking, and in order to get as much juice out of them as possible. It's time to wrap up. We've had over 150 people join in real time throughout. So thank you all for joining, for sticking around. Do check out all the other things we do, other workshops we have, everything's in the description. But most of all, thank you, Nico, for coming and sharing all this cool stuff with us. And the repo, of course, everyone jump into the repository as well. And I'm really excited to see what happens next at AMP, Nico.
Nice. Thanks for having me. And the next time when you invite me again, should you invite me again, I will
I
figure
can't
out
wait.
how to properly set screen permissions for Zoom.
That was the least of our problems. Awesome. See you all soon. And scene. That was awesome, man. And I'm
Nice.
so glad I got to be the harness.